So let's take the derivative of four functions that can be expressed as a composition of functions and see what this chain rule is requiring us to do. The first one is going to be the composition of functions that we started with in the very first video. We'll let f of x equal x squared plus 3x raised to the fifth power. Now, for the sake of learning this, I want to identify what the outer function is and what the inner function is. And remember, the outer function is going to be the one that's acting on the inner function. So the outer function right here, at the end of the day, what I have is I have something being raised to the fifth power. So the outer function is really just simply x to the fifth. The inner function is what this x is, and so the inner function is x squared plus 3x. Now, what the chain rule requires us to do when we take the derivative of f, so f prime of x, is I take the derivative of the outer function. So the derivative of x to the fifth, we know very clearly, is 5x to the fourth. But if I take it at the inner function, then instead of saying 5x to the fourth, I want to say 5 times whatever this is to the fourth. So 5 times x squared plus 3x raised to the fourth. And you can kind of see, as we look at what f of x was, that almost would instinctively be the first step anyways. Take the 5, bring it out in front as a coefficient, reduce the power by 1. What the chain rule says is because I have this inner function here, that it was the composition of functions, I need to multiply it by the derivative of the inner function times the derivative of x squared plus 3x. This part right here really is the part that we would say is the chain rule step. So now if I take that derivative, I get f prime of x equals, leaving this, I get 5x squared plus 3x raised to the fourth times the derivative of x squared plus 3x, which is just going to be 2x plus 3. And that's the derivative of f right there. There's really not a lot more I could do to simplify it. And so that's going to be my f prime of x. And that's the process that really happens here with the chain rule. All right, let's take a look at a second function. Let's look at g of x equal to the sine of x squared. Again, this is not the sine of x, it's the sine of x squared. So I have a sine function and an x squared function. So I need to identify which function is my outer function. It is the sine function that's acting on x squared. So my outer function is the sine of x, or the sine of something. My inner function is x squared. So when I take the derivative of g prime of x is the derivative of the outer function. Derivative of sine is cosine of x, but I don't want to take it of x. I want to take it at the inner function, so the cosine of x squared times the derivative of the inner function, x squared. Well, the derivative of x squared is 2x. Just kind of in terms of style, you would write that in front of the trig function. So we would say g prime of x is equal to 2x cosine of x squared. And there's your derivative. Again, because it was a composition of functions, you had to apply the chain rule. All right, let's take a look at two more examples here. We'll kind of block off our area just to separate our work. Let's take a look at h of x equal to the square root of x squared plus 3x minus 5. Again, I have a composition of functions. I have a square root function, and then I have this quadratic function, x squared plus 3x minus 5. It is the square root function that's acting on the trinomial here. So my outer function is just the square root of x. My inner function is x squared plus 3x minus 5. So when I go to find h prime of x, the derivative of h with respect to x, it's the derivative of the outer function. Hopefully you'll recall the derivative of the square root of x is 1 over 2 square roots of x. So it's going to be 1 over 2, but instead of the square root of x, I want to take the square root of the inner function, and it kind of retains what's happening here. In fact, you can kind of see that that happened on each of the examples so far. So x squared plus 3x minus 5. And now what the chain rule says, so there's the derivative of the outer function at the inner function, Now I need to multiply by the derivative of the inner function. So I need to multiply by the derivative of x squared plus 3x minus 5. Well, this derivative right here is going to be just 2x plus 3. And if I multiply it all together, I can write that in the numerator and say h prime of x is equal to 2x plus 3 all over 2 square roots of x squared plus 3x minus 5. And so there would be my derivative. And again, you can kind of see it is the derivative of the square root of something, which is 1 over 2 square roots of something. The chain rule part is what gave me the derivative of that inner piece that I took the square root of. All right, last example that we'll look at here in this video, and this is kind of more of a notational thing than anything. J of x equal to the cosine squared of x. This is a composition of functions. If it helps you to remember what this is, we write that cosine squared of x to represent the cosine of x quantity squared. And we write that way to remove any ambiguity so it doesn't look like this. This was the sine of x squared. This is the cosine of x, all of that quantity being squared. But it is a composition of functions. If I take a look, it's the square function, that quadratic parent function, acting on the cosine of x. So my outer function is simply x squared, and the thing that's being squared, this inner function, is the cosine of x. So when I take the derivative, when I take j prime of x, it's the derivative of this outer function. Well, the derivative of x squared is just 2x. Now then, instead of x, I'm going to replace it with the inner function here, which is the cosine of x. And then the chain rule says I need to take the derivative of this inner function. So times the derivative of the cosine of x. And again, that's your chain rule step. Well, the derivative of cosine is negative sine of x. And so if you can kind of visualize that, I can rewrite that and get my answer here for j prime of x. Again, this is negative sine of x, so the negative will come out in front of the 2. Negative 2, and then I just write the sine of x, cosine of x, and hopefully you can see where each of those pieces come from. But that's what j prime of x is. And so in each of these cases, you can see the chain rule step was the action of taking the derivative of that inner function. So again, as you work through these moving forward, you won't always stop what you're doing to identify the outer and inner functions. Hopefully that comes natural to you over time. But understand that you do have to take the derivative of the outer function at the inner function and then multiply it by the derivative of the inner function, and that's what the chain rule says we have to do.